All right, so this was a very important part of this. Up here, they already told you which way to solve these. But down here, you kind of have to start deciding on your own. So, Madison, can you help me with this one real quick?
Yeah, I'm
All
like,
right.
I'm not exactly sure how to do it.
Okay, so you and I are going to have a conversation so that that fixes it, okay?
Okay.
All right, so first off, do you understand what they, when they say square root, what did I tell you you were supposed to think? Do you remember that?
Not really.
Okay, so I called it isolation. Do you know what isolation is?
Like separating
Yep,
things.
getting something by itself. So I want to get the x by itself if I'm going to do isolation. Okay? The only problem is I can't get x by itself because do you see there's an x squared and there's an
Yeah.
x? Those two x squareds and x's will never combine. So I can't do this by isolation. So would I want to do square root, aka isolation for this one?
No.
No. Why? Because there's two types of x's. Okay. This is now it's a big class. It's not like this is just like when you're in middle school where okay, this is how you solve it, or in elementary school how you add and things like this. Now we have different processes for solving equations. It's legit like things in life. Um, I am currently redoing a house for those of you who are new to my class. And when I'm redoing my house, Madison, let's say I have a plumbing issue, I go to Home Depot and I tell them this is what I want done. How can I get that done? And the guy will like draw me out a picture. I talk to him. I get his solution. I then go to Lowe's and I talk to the plumbing guy in their section. And 9 times out of 10, he gives me a different way to solve my problem. I then look at the two solutions that they've given me and I find the cheapest, depending on which one has probably being cheaper. But if the easiest and cheaper one is together, that's great for me. But I pick which solution is going to be best. That's kind of the same thing we're doing here. Like I could solve this by doing a bunch of these. I'm trying to find the easiest one of these to get this job done. Does that make sense, Madison?
Yeah.
So getting isolation means getting the x by itself. That's you need to know why you'd want to do it and what scenarios you'd want to do that. Do you see this one right here, number 2?
Mhm.
How many x's do you see in that? How
One.
many how many types of x's do you see, I should say?
Um.
You see one. You're right.
Yeah.
Just x squared, right?
Mhm.
That's when you want to isolate because there's only one type of x. You can get everything away from the x and make it just say x equals. Does that make more sense now or no?
Yeah.
All right, Noah. Noah Brown.
Yeah.
Do we want to solve this by factoring? Do you remember the factoring rules?
No, I do not.
Okay. So again, some of you are going to have to put in a little more work than what we've been doing because you came into my class maybe late. There are factoring rules. Let's see, Kelly, just because I think you said you actually watched the video.
Sorry, could you say it again? My internet's kind of being weird.
What would I want to use this by factoring? Would I want to solve this by factoring?
Yes.
What does this sign tell me?
That the signs are going to be the same.
And what else? Whenever I have same signs, what else did I do with the two numbers to get to the middle?
That they're gonna add up together.
Yes, yes. That's huge. Yes. So that means I'm going to take two numbers that multiply to 3, but add to 4. And are there two numbers that multiply to 3 but add to 4?
Yep, 3 and 1.
And so that's why I want to solve this one by factoring if possible. So my answer for this would be factoring is the way I want to solve this. And why? Because there's two numbers that multiply to 3, but add to 4. I've been showing, and if you haven't done it, like I said, I've showed you guys in this class, you need to watch my YouTube if you don't know about factoring because it's not going away. But you can't just factor whenever you want.
Mr. Martin,
Yes.
I don't know if I misheard you or not because my Wi-Fi has been weird, but did you say we have a quiz this week?
Yep.
What day?
I'm not 100% sure, but either Wednesday or Thursday, somewhere in there.
And what are they gonna like? Is it gonna be like
2, 4 to
2.6?
2.6.
Okay, thank you.
Uh-huh. So right here, if I have this, see, some kids think that this is factorable because there's two numbers that multiply to 6 and add to 7, because 6 times 1 is 6 and 6 plus 1 is 7. But you can't go against the laws of the signs, which this says I need different signs, which means they're supposed to subtract. So that means I need two numbers that multiply to 6 but subtract to 7. And there are no two numbers that multiply to 6 that subtract to 7. So this is not factorable. And the reason they get this messed up is because there are two numbers that multiply to 6 and add to 7, but you can't make them add because the signs tell me they must subtract. It's so important to follow the sign rules. And some of you have no idea what I'm talking about, but that's because you didn't actually learn how to factor and understand the basics of factoring. That's why you need to watch those videos from my channel that before you got here, we went over in my class. So yes, I do want to solve that one by factoring. Destiny.
Yeah.
The next one. Do I want to solve this number 3? We already went over this one. We said we want to isolate it. Do I want to solve number 3 by doing isolation?
No. Yes.
That sounds like a question, and it's like that's what I'm trying to get rid of.
Right.
We're trying to make it to where we're not just guessing at what we do in math, because math is not guesswork.
Yeah.
There is a reason why I'm going to do the process I'm going to do. What did you hear me just talk just recently about this isolation?
Yeah.
Okay, when did I say we want to isolate?
When there's only one type of X.
Okay, so let's look at this. It's not guesswork. This is an X squared. This is an X.
Yeah.
Are those the same type of X's or are they two different X's?
They're different.
So do I want to isolate this one?
No.
That's not a question. It's a 100%. I know I'm not going to solve this by isolation.
Right.
Now, be careful because I'm not saying this. We'll make that a 19. I'm not saying that you can't solve it if there's two X's. I said two different types, right? Do you see how this is an X and this is an X? But what can those X's do together?
They can combine.
So you can actually do this one by isolation. Whereas if you have 5x squared plus 10 minus 3x equals 19, I'm talking about two different types. X's and x squareds don't combine, so you cannot isolate this one.
Right.
You see the difference?
Yeah.
Okay, so that's what I've been trying to, that's my way of teaching, is to show you the whys behind what I'm doing. It's not guesswork. It is, I know 100% sure. All right, thank you. Now try to keep, if you have a question on anything I'm saying from now on, I know I'm not talking to you, Destiny, like directly from now on, but anytime I'm talking, I am talking to you. And I need you to ask, stop me and say, Mr. Martin, I don't understand what you just said. That goes for every one of you online. You've got to be more active in, I don't get it. Can you please come back over it? Jonah Duncan. Remember, I told you, even if you can't stay in the mic, you should comment back to me in the comments. Samantha.
Yes.
Do I want to solve this one by factoring?
No.
Why not?
Because there's two types of x's there.
That's for isolation that you do that.
Uh, none of the numbers add up, subtract to 7.
Okay, you're close. I appreciate you trying. You're very close. This says that they're same signs.
Mhm.
As soon as I know they're same signs, I have to add. So that means I need two numbers that multiply to 1, but add to 7. And you're correct. There's no numbers that multiply to 1 that add to 7. So factoring is not good. Okay, you're good. Nina?
Yeah.
Do I want to solve this one by possibly completing the square? This is something we haven't talked about yet today.
No.
Why not?
Because B is odd.
Yes, this does have a square root, which is nice. So I go, okay, I could possibly complete the square. Then I look at the B and see that it's a 7, which if I divide it by 2 is not a nice, pretty number. So I do not want to complete the square. So finally, I'm going to use the quadratic formula to solve number 3. Is this making sense now?
Yes.
Questions on this? All right, number 4, Ashton.
Yeah.
Do I want to solve this one by isolation, bud?
No,
Why not?
because there are two x's.
Two different types of x's, right? Good.
Yeah.
All right. Isabella,
Yeah.
do I want to solve this one by factoring?
Yes.
Do you see how there's question in your
Yeah.
I want to get rid of that because to me that means you don't know really yes or no. So hold on 1 second.
Okay.
All right, so what I mean by that is did you watch the factoring videos that I keep referring to?
Yeah.
Okay, so remember from our factoring video, what does this plus sign back here tell me? Because it tells me something. It's like I'm a detective and I'm coming in to a crime scene and I'm using the clues that I have. What does this clue me into? What does that plus sign? It tells me two things.
It's adding.
That's one.
Okay. And it's positive.
No. So the only way to get this, the only way to get a plus sign back here is the C, is if I take the last number and times it by the last number, right? What's the only way I can kick to a positive? Is a positive number times a positive number. This times this is where this comes from. Or a negative times a negative times a negative also kicks to a positive. So as soon as I see a plus sign back here, I know that in my bubbles, it's either plus plus or minus minus. I know it can't be 1 plus and 1 minus. I know that's for sure. That's what those videos are supposed to kind of help you understand. Does that make sense?
Yeah.
So I look at this and I go, okay, since that plus sign right there, I know that it's either plus plus or minus minus. This tells me that they would both be plus plus. But the big thing is it tells me that they're same signs and so I have to add. Meaning I need two numbers that multiply to 4 but add to 10. Are there two numbers that you can think of in your head that multiply to 4 but add to 10? The answer might be no.
Yeah. No, because I was doing that in my head. No.
4 times 1 is 5, or 4 plus 1 is 4 plus 1 is 5, right?
Yeah.
2 times 2 is 4, 2 plus 2 is 4. There's no two numbers that multiply to 4 but add to 10. So what does that mean for this one?
No.
We're not going to factor it. Not going to factor it. Noah G. Not looking good. Ashton or Austin, sorry. Austin.
Yeah.
Do I want to complete the square with this one? Is it a possibility for completing the square problem?
Yes.
Do you see how again how there's question, and when I talk there's no question?
What?
Do you see how there's questioning in your voice when you say you're like
Yeah.
yes?
I don't really know.
Right, and that's what we need to get rid of. It's not a question. It is 100% yes, I know for sure I want to use this, or no, I don't, and there's a reason why. When I do completing the square, Austin, this number has to have a square root. Does this number have a square root?
No.
It does.
Oh, it does.
Yeah, what's the square root? If I took x squared, what happens to the square and the square root? They cancel, leaving me with just x. So this is a square root.
Okay.
In order for this to be possibly a complete the square, this has to have a square root, which it does. So it checks the first box. The next thing has to happen is this has to have be divisible by 2, which it is. So I would want to do completing the square for this problem. Does that make sense now?
Yeah.
Can you go back to that, to that writing you just said?
Yep.
All right. Can you leave it up for like 30 seconds?
Yep. You can take a picture of it too if you want.
All right, I got it. Thanks.
All right, so this right here, let's actually, because I want to practice factoring or solving using the perfect, the completing the square, because I think that's the one we probably have the most trouble with. So right here, I would check by factoring and see if this is a perfect square. This has to have a square root, which it does. This has to have a square root, which it does. But this times this is 2x, and then doubled is only 4x, and that's 10x. So it's not a perfect, this is not a perfect square. So I'm going, okay, that's not good. If it was a perfect square, I would just factor it. But since it's not, I go, okay, I'm going to get rid of you 4 and move you over. And then I'm going to take the x squared minus 10x, and I'm going to add some number. I don't know what number yet, but I'm going to add some number to make this trinomial a perfect square. The way I do that is I go, okay, the square root of this is x. This divided by 2 is 5x. This times this has to get me to the 5x, so I'm missing the 5. And then this is the square root of what would be missing, so I'm adding 25. If I add 25, that now makes this a perfect square. But if I add 25 to one side, I have to add 25 to the other side. The whole purpose of this making it a perfect square was so I can actually factor it. The way that I factor this is the square root goes here, the square root goes here, the sign of this is right there. And then -4 plus 25 is 21. And the way I solve the rest of this is I square root it. I square root it, I get x plus 5 equals, since I put it in, plus or minus the square root of 21. If I break down 21 because I want to see if it's reducible, it just breaks down to 3 times 7, which are both prime, and there's not enough to pull anything out because that's just 3 to the first, that's just 7 to the first. 2 doesn't go into either of those, so it just stays the square root of 21. That's as simple as it gets. I minus 5 from both sides, and I get x equals -5 plus or minus the square root of 21. And that would be my final answer for completing the square on that one. All right. this one completing the square. Daniel. Daniel, I can't hear you. I think you're unmuted, but I can't hear you. Daniel, try again. I muted you. See if you can unmute. No, it's still not working, Daniel. It's all right. Eric? Eric? Dominic?
Yeah, I'm here.
All right, help me out, Dominic. Do I want to solve this one? Isolation number 5.
No,
Why not?
there's two different x's.
Good. Savannah? Savannah? Josh?
Yeah.
Do I want to solve this one by factoring?
Here, let me see. Which one?
Do I want to solve this one by factoring?
Yeah.
Well, before I can solve it by factoring, I have to make sure it's equal to 0, Josh. So how do I make this equal to 0? What can I do?
You can take 5 from both sides.
So then I minus the 5. Now, Josh.
Yeah.
What does this sign tell me?
That it's going to be negative?
Nope.
Or your signs aren't going to be the same?
No. Different.
Yeah, that's what I meant. I said they're not going to be the same like they are.
I thought I didn't hear you. So they're different, which means what else does that mean?
That means that you'll have like an x minus.
It means what I'm looking for is that if I know they're different, it means I have to subtract to get to my middle number.
Yeah.
So that means I need 2 numbers that multiply to 5 but subtract to 14. Do you know of any numbers that multiply to 5 but subtract to 14?
Multiply.
The only numbers that multiply to 5 are 5 and 1, and 5 minus 1 is 4, which is not 14. So that means this is not going to be solvable by factoring.
Oh.
So nope, don't want to factor. Do I possibly want to complete the square? Janina, do I possibly want to complete the square?
I would say no.
Okay, why would you say no? And I'm not trying to be like mean on you guys, but it's not a feeling. It's not like something that you look at and you go, you know what? It's not a feeling. There's rules on why you want to do completing the square, why you want to factor, and that's what I'm trying to bring to your attention.
Well, to me, it seems like it'd be simpler just to do the quadratic formula.
Quadratic is going to take a long time. Whereas, does this have a square root?
Yes.
What is it?
X.
Is this divisible by 2?
Yes.
I would say I would do completing the square. Anytime that I can do it and it's nice and pretty, it's not terrible, meaning this is x, this is 7x, this times this has to be 7x, so I have to add 49. I have to add 49. X minus 7 squared equals 64. No, 54, sorry. I mean, I think that completing the square, I'm almost already done with this problem, whereas if I'm doing the quadratic, I'm still probably just plugging the equation in. Do you get what I mean by that?
Yeah, I mean,
I think don't shy away from completing the square because you don't understand the process yet. Because once, you know how like if you keep doing something, it gets easier?
well, I see how you do this, but to me it just seems simpler for how I do my math to do the quadratic. It's just quicker for me.
Okay. Just remember on the test, you won't have the time. If you try to do everything with quadratic, you won't finish it.
Okay.
Okay. This right here, then you would square root it. It becomes x minus 7 equals plus or minus. We got to break down 54. 9 times 6. 3 times 2. 3 times 3. Square root of 2 times 3 cubed. 1, 2, 3, right? How many times does 2 go into 1? It doesn't. So sorry, 2, you got to stay inside. How many times does 2 go into 3? 1 time with 1 left over. So then 3 square roots of 6 is what I get, is the same thing as the square root of 54. It's just the simplified version of it. I add 7, and I get x equals 7 plus or minus 3 square roots of 6. That's completing.
How'd you get 6 in the square root?
Because who asked that?
Ashton.
So Ashton, do you understand everything up to the part where I got it to the square root of 2 times 3 cubed?
Yeah, I understand all that.
Okay, so there's an imaginary 2 here. How many times does 2 go into the power? Because every time you have a square underneath the square root, they cancel out, right?
Yeah.
But I have a 2 to the first power, so the square and the square root aren't canceling out. So I say, sorry, 2, you don't have enough to come out.
Okay.
How many times does 2 go into 3, though?
Once.
So that's why I get 2 to the first power out, but there's 1 left over, correct? Because 2 goes into 3 one time with 1 left over. So what's still left inside my square root? Oh, sorry, this is a 3.
1 square root of 3. I mean,
Right.
just one. Yeah.
There's a 2 and a 3 left over. So what's 2 times 3?
6. Okay, I get it now.
That's where the 6 came. You have to, whatever's left over, you got to multiply back together.
Okay.
All right. Taylor,
Yeah.
for number 6, would I want to isolate it?
Yeah.
Heck yeah, why?
Because there's only one type of X.
Yes, absolutely. Annabella,
Yes.
number 7. This one, do I want to isolate it?
Like put the 10 into it?
Mm-mm. What does isolation mean?
I don't know.
Okay, we've been going over that the whole time. Isolation means that I get the x by itself. Do you see this right here?
Yeah.
See how there's only one type of x?
Mm-hmm.
That means I can get the x by itself. I can get everything else away from the x and make this just say x equals. Do you see how there's 2 types of x's here?
Yeah.
That means I do not want to isolate this one. I can't, because I have x squareds and x's which will never ever combine. They're not like terms. So this one is not possible to isolate.
Okay.
Robert,
Yes.
do I want to factor this one?
Number 7.
Yep.
I said no factoring.
Why? But before I can decide if I have factor, what do I have to do first?
You have to look at the signs.
Yeah, but what's the problem? The way they wrote it.
There's no third number.
So what can I do to make that happen?
You can find the square root of x, x squared, my bad, which is x, and then plus x, so that would be 1.
So you're trying to complete the square?
Yeah.
I would not complete the square because this is not even.
Yeah, you can't really do.
Well,
either
look.
factoring or anything.
Well, before we try to decide whether this is factorable or not, Robert, I got to move this. In order to see if it's factorable, it has to be set equal to 0.
Yeah.
So before I can decide if I'm going to factor it, what do I need to do?
Subtract 10.
Yes.
So
Now,
this one I don't really have. I have no isolation, no factoring, no completing the square. I just have quadratic.
right, but what I want you to make sure you understand before we decide whether it's factorable or not, we got to move this crap over.
Yeah, I know.
So then this says that they're different signs and I subtract. and I need two numbers that multiply to 10 but subtract to 1. The only numbers that multiply to 10 are 1 and 10. Those don't subtract to 1. 2 times 5, those don't subtract to 1. So that's why it's not factorable. Does that make sense?
Yeah, I know.
Kelly,
Yes.
do you want to solve this one by completing the square?
No,
Why not?
because x squared is a perfect square, but x isn't divisible by 2.
Right. Yes, it's not nice and pretty when we divide it by 2. Absolutely perfect. Tucker.
Yes.
What does that mean I need to do then with this one? Stay unmuted, Tucker.
I don't really know.
Well, that's the problem. That's what we're trying to fix here, bud. What's the only thing left up here?
The quad form,
Do you know what that stands for?
quadratic formula.
Yep. Do you remember what the quadratic formula is?
No.
It's a long formula that says opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. It's what we did the other day in class. But the problem is, how come I can't define what my a, my b, and my c are?
Because we don't know what x is.
No. Okay, so Tucker, you might want to go back and review the 2.6 video that we went over in class, because it seems like you weren't here or paying attention very well. This right here, I can't have this over here. In order to use the quadratic, it has to be equal to 0, so I'm minus 10. So this right here is now the formula I'm going to use. My a, the number in front of this. My b is my number in front of this, and this is my c. So that tells me my a is 1, my b is 1, and my c is negative 10. So then this is what I would plug in for my a right here and here, my b right here and here, and my c right here. But before I could use my quadratic, the way they give it to me would not work. I had to make it equal to 0. Orist?
Yes.
Would I want to solve this one by using square roots or by isolation?
Wait, let me see.
Number 8. Orist, just look at it. When do we know we want to use isolation?
If there's only like one x.
Is there one type of x here just looking at this?
No.
Thank you. Sierra. All right. So the next question is, do I want to solve this by factoring? X squared minus 4x minus 12 equals 0. This right here tells me that the signs are different and I need to subtract. I need to look for two numbers that multiply to 12 but subtract to 4, 6, and 2. So that means, yes, I want to do this by factoring. And to do that, this tells me the bigger sign is negative, so my bigger number is 6, so it's going to be x minus 6. X plus 2 equals 0. What makes this bubble 0 is a 6. What makes this bubble 0 is a negative 2. And that would be my two answers. That was the major point of this. I did a lot of the solving for it. You need to make sure you understand all the different ways and how to actually solve them. Does anyone have any particular questions on any of the other homework that we did for that? I said this will be what the majority of your test is on either Wednesday or Thursday.
I had a question on number 1 on page 4 from that worksheet.
Okay, what is it?
Y equals 2, and then parentheses, x plus 2 squared plus 24.
And so they made it equal to y. They should have made it equal to 0. That might have been one thing that threw you off. And
No,
then,
I got the 0.
okay, well, how many types of x's are there, Nina?
1.
So guess what process I want to use?
Isolation.
And that means, yep, that means I'm going to work backwards on my order of operations. It means I'm going to get, this is my problem. I'm going to work backwards to get to it. So if I was doing top to bottom, I would add the 2, then I would square it, then I would times by 2, then finally I would add to 24, and that would get me to 0, right?
Yeah.
So I'm working it backwards. So I'm going to undo what I did last, which was add the 24. So I'm going to undo that. I got rid of my addition and subtraction. I'm working backwards on this. Negative 24 equals 2x plus 2 times, or to squared. This right here says you're multiplying by 2. That's what I get rid of next. So I divide by 2. Don't distribute that. That's a common error. Do not distribute that. Negative 12 equals x plus 2 squared. Now undo squaring by square root, plus or minus I, and then take the 12, 4 times 3, 2 times 2, square root of 2 squared times 3. 2 goes into 2 once, so I get a 2 out, none left over. 2 square roots of 3, but it's going to be 2i square roots of 3 equals x plus 2. I minus the 2, minus the 2, so my final answer would be negative 2 plus or minus 2i square roots of 3 equals x. Did that make sense, Nina?
Yeah, that did. Thank you.
You're welcome. Isolate, don't distribute. That's the common error. Did you try to distribute that?
I can't really remember what I was trying to do, but I wrote down factoring, so.
Yeah, no, we want to isolate because that x is by itself. So I'm going to work backwards on my order of operations to isolate the x so that it's by itself and everything else is on the other side. All right. Other than that, you guys have a wonderful day. There will probably be a review or something posted on Portal, so make sure you look for it.
Have a good day.
Thank you too.